All right, hi folks, this is Larry Mussolino. A few students were asking for a little bit of help with truth tables here in Module 1 of MAT230. So I thought I would record a short video here and give you some background on how to set up these truth tables. And I think a key for this is creating these intermediate columns in the truth table. I'll show you what I mean by that in a second. First, let me mention that when you get started in Module 1, you're going to see that we use letters like P and Q to represent these statements. So P might be the statement, "It will rain today." And that statement's either going to be true or false. Let me give you another. Q is, "I will wash my car today." Again, that's a true or false statement. The other thing we do with these statements is we connect them. And we can either use a not, and, or. And these are the symbols. For example, if I use P with this up caret Q, this is P and Q. In my example, it will rain today and I will wash my car. If we use this V symbol like this, it means or, P or Q. It will rain today or I will wash my car. All right, so what we'd like to be able to do is take these statements and create a table that covers all possibilities. And so one thing we're going to need to know is, how do you set up this table, this truth table? Well, if you have two statements, P and Q, then the table is going to have 4 rows. I'll show you this one in a second. What if you have 3 statements? Usually we'll use P, Q, and R. Well, this is going to have 8 rows. Now, the way you can think about it is, if you have P and Q, P can take on 2 possibilities, true or false. Q can take on 2 possibilities, true or false. To find the total number of combinations, you multiply these together. So 2 times 2 is 4. What if we had P and Q and R? Well, again, each one of these can be true or false, so each one can take on 2 different outcomes or 2 different results. But if I multiply these together, 2 times 2 times 2 is 8 rows. Now, when you go to set up these tables, there's a certain setup that you use. Let me show it to you. So let me go and do an example of a truth table with 2 statements, P and Q. Then I'll do another more complicated example with 3 statements, P, Q, and R. But let me start out with just P and Q. So the way you set up a truth table like this is you set up 4 rows in the table. So let me call this row 1, row 2, row 3, row. Okay. And so what you do for P is you split up the 4 rows and make the first 2 be true and the last 2 be false. For Q, I'm going to alternate. I'm going to write it as true, false, true, false. So again, the way I set up P is I put 2 trues in the first 2 rows and then 2 falses in the last 2 rows. And for Q, I alternate true, false, true. This covers all the 4 possibilities of, the truth or true or false for each one of these statements. For example, both P and Q might be true. Both P and Q might be false. P could be true, Q could be false. P could be false, Q could be true. Those are the only 4 possibilities, or the only 4 combinations of what can happen for 2 variables. Sometimes we call these variables P and Q. All right, well, I want to come up with a truth table. So here's a problem. Create a truth table for this compound statement. Not Q or P and not P. Okay, so here's a complicated statement, and we want to create a truth table. Now, one thing we have to know about is, what do these operations really do? Well, not, you can kind of figure that out. Probably not means flip the true false status. So if you're starting out with P being true and you evaluate not P, well, that's going to be false, right? So this not operator is flipping the true false status. What about and? Remember, this up caret is and. And is true only when both P and Q are true. And it's false otherwise. How about or? Or is true when either P or Q are true. This probably matches your intuition. You know, for two conditions to be, for A and B to be true, it has to be that both A and B themselves are true. All right, so let's go ahead and create this truth table. Now, here's what I'm noticing. I'm noticing that we need not Q. So I'm going to create a new column for not Q. Here's not Q. Well, I know that means flip the true false status of Q. So let me go to the first row. The first row, Q is true, but I got to flip it to be false. Second row, Q is false. I got to flip it to be true. You could see I'm going to flip each row for Q into this not Q column. All right. You know, actually, I think I'm going to move this table up a little bit. Or let me see if I can scroll down here to get, maybe that's a little better. Trying to just get some free space there. That's okay. All right, let's keep going. We have not Q. I want to create a new column now for this combination of not Q or P. So here's my new column. It's going to be not Q or P. Remember, this symbol is an or statement. All right. So to fill in this column, what I have to ask myself is, take the not Q column and compare it with the P column. This is going to be true when either any of the two variables are true. So I can kind of go and look at the not Q column. Anywhere I see a true for that, this green column is going to be true. So I'm seeing here's a true, so that row is a true. Here's a true, that row is a true. Let me go to the P column. Anywhere I see a true in the P column, the green column is going to be true. So this first row, P is true. That means this or column is true. The only time the or is false is if both the two statements are false. Well, this row right here, not Q is false, and P also is not false. So this is false. All right, so we took care of this part. Let me make a new column now for not P, because I need now this not P portion. So I'm going to make a new column here for not P. Well, I know that just means flip the true false status of P. So I'm going to come here to this first column, and I'm just going to flip each true false. The first row is true, so I got to flip it to be false. Second row is true, flip it to be false. Third row is false, flip it to be true. Last row false, flip it to be true. All right, I'm ready now for the last column. And for the last column, I'm going to put it all together. So for this last column here, let me erase a little of this stuff right here. For this last column, I'm going to make this not Q or P and not P. Let me label these columns. Maybe it'll be a little easier. I'm going to call this column 1, column 2, column 3, column 4. Here's column 5. All right, really what I'm doing is I'm taking column 4 and doing an AND connector with column 5. Now, I know AND is true only when both of the variables are true. So I'm going to be comparing the green column and the purple column. And wherever I see both true, I'm going to fill in true in the last column. So let me do a little bit of a check here. I'm noticing this bottom row, column 4 is true and column 5 is true. That means this row is going to be a true. There's no other row where both the green column and the purple column are both true. So this first row is a true and a false. Well, that leaves me a false. The second row, true and a false. Again, that's a false. The third row is false and true. That's a false. Remember, this AND connector is true only when both variables are true. So here is my final answer in this rightmost column. So you notice why I built up this table. I created column 3 for this part. I created column 4 for this part. I created column 5 for that part. And then column 6 was the entire statement. It's too difficult to do this without these intermediate results, I think. So I recommend you create these intermediate columns like this. All right, let me do one more example here. Maybe I could do one with 3 statements, P, Q, and R. Let me go down here into ZY Books. All right. How about if we do, maybe we could do this example. All right. So I'm noticing this example says, create the truth table for not Q and P or R. Now, you also have to take into account parentheses here. Parentheses kind of tell you the order of how to proceed. The first thing I'm noticing, and by the way, notice here we have 3 variables, P, Q, and R. That means we need 8 rows. So here's the setup that you use when you have 3 statements like this, P, Q, and R. Look at the P column. Notice the first 4 rows are true. The last 4 rows are false. Let me go to the Q column. Now this is going to stagger it as 2 and 2. 2 trues, 2 falses. 2 trues, 2 falses. So it was 4 and 4 here. And over here it was 2, 2, 2, 2. Now the rightmost column alternates. True, false, true, false, true. So this setup is always the starting point for your truth table. So if you're using 3 statements, P, Q, and R, your truth table is always going to look like this example to start with. All right, well, let me look at the statement that they're asking me about. I'm noticing not Q shows up. So I'm going to need a column here for not Q. So let me start to create that. Well, I know not Q is just going to be the opposite of the Q column. So I'm going to go to this Q column right here and flip the true false status. The first row is a true, flip it to false. Second row true, flip it to false. Third row false, flip it to be true, and so on. So I'm just going to copy these results here. All right, so we have the not Q part done. Let me look at this parenthesis here. This parenthesis is P or R. So P or R. Now, if you remember, the OR connector is true when either statement is true. All right, so I want to compare the P column and the R column here. If I see any true in either the P or the R column, this blue column is going to be a true. So let me go to the P column. Well, the first 4 rows are all trues. That makes this OR column have the first 4 rows as true. Let me go to the R column. Here it is. Well, anywhere I see a true, that's that row, and this row, I'm going to use a true. The remaining rows, let me see if I could circle these in purple. This row has a false, false. That makes this a false. And this bottom row is false, false. That makes this false. All right, we've done that column. One last column to put it together. Here's the final column. We need not Q and P or R. So remember, this is the AND connector. AND is true only when both statements are both true. And it'll be false otherwise. So let me look at these 2 columns. I'm going to look at the pink column and the blue column. I'm looking for true, true. The first column is not true, true. It's a false true. Let me go to the second column. False true. No good. Here, this third row is a true, true. So that row is going to get me a true here for the AND. This next row is a true, true. So the AND for that is a true. And here's one more down here, true, true. So that row is a true. All the other rows are not both trues. That means all the other rows are going to be false. So there's a false there, a false there, false, false. So here is my final answer in the rightmost column. And again, I created this final column by building it up one step at a time. So notice I created these intermediate columns. Okay? All right, folks, hope this is helpful to you as you're working in Module 1 here. Please let me know if you have any questions.